fraction together. Let's get into it with our I will statements.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these 3 things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen as I read the first one. I will decompose mixed numbers. Read that one with me. I will decompose mixed numbers. And our next one. I will add a fraction and a mixed number. Read that one with me. I will add a fraction and a mixed number.
For one of your reviews today, you are going to be playing Around the World. How this game works is you will each start by sitting on top of your desk. While you are sitting by your desk, one student will stand by the person next to them. Each of the students will be shown a math problem at the same time. It might be a multiplication problem, addition, subtraction, or division problem. Your job is to say the answer as quickly as possible. Whoever says the correct answer moves on to the next seat over. If you answer incorrectly, you move and sit in your seat and watch and cheer your friends on. The goal of the game is to get all the way around the room by answering all of the facts correctly. I will post the rules on the screen for you to pause and talk about. If you have any questions, ask them now. Come back and play the video to see which math problems you will be using for this round of Around the World.
All right, mathematicians, let's get into our activity today. We'll be working with mixed numbers and fractions. On your whiteboards and with your markers now, I want you to write this addition problem. Pause the video and do that now. If we were to say this expression in unit form, we would say 2 ones for the whole number, 3 eighths for the second part, and then we're adding another 3 eighths. I want you to say this addition problem with me now. 2 ones, 3 eighths plus 3 eighths. If we were looking at this problem at the units that were involved, we have ones and eighths. When we add numbers, we like to add like units. So since we have ones and eighths, on our whiteboards, let's underline and write this on yours. So we have 2 ones. Ones is 1 unit. And we have 3 eighths twice. Eighths is our second unit. If we were going to look at how many ones there are in total, we would look to see that we have 2 ones. That's right over here. We're going to put a little equal sign next to here. In total, we only have 2 ones. So let's write 2 ones in our answer. Now we need to look at our other unit. How many eighths are there in total? If we were to look at it, we have 3 plus 3. What's that? 3 plus 3 is 6, and our units is eighths. So if we were to say this addition problem in total, 2 ones, and 3 eighths plus 3 eighths equals 2 ones and 6 eighths. 2 ones and 6 eighths, if we were going to write it as a fraction, would look like this. We write 2 and 6 eighths just like this. Now, let's show this addition problem using a number line. Let's start by drawing our number line. I'm just going to move my whiteboard up and draw my number line underneath it. Our first step on our number line is going to be to start at 2 3/8. So we need to figure out 2 3/8 is going to be between the whole numbers 2 and 3. So let's put that onto our whiteboard here. Since we have our units in eighths, let's split up our number line into 8 individual parts. So we're going to draw 7 lines. 1, 2, 3, 4, 5, 6, 7 to represent the eighths that we split this up into. Now, if we wanted 2 3/8, we would have to count 2. Let's count over 3. 1, 2, 3. Here is 2 3/8. Let's label that on our number lines now. Since we split this up into eighths, we just have to add 3 more jumps onto our units since we already are in eighths. So let's count up 3 more. 1, 2, 3. So we added 3/8. Let's add that there. Would bring us all the way over to 2 6/8. Write that on your whiteboards now. Notice how that the ones in our case stayed the same. It's still a 2, and the only thing that changed was our fractional units. That's because we simply just added together the fraction and the sum was less than 1. Now, this isn't always the case. Sometimes your units or your whole units might change depending on if your fraction goes past another whole number. Let's look at a quick example of this now. Keep your number line on your whiteboards, but erase the top part of your number lines now. We're still going to use 2 3/8, so we left our number line and make sure that unit is still labeled on your number line. If we had 2 3/8 and we just tweaked our math problem a little bit, so we added a different fraction to this mixed number, let's add 5/8 now instead. If we were to look at this, we're still given the same amount of ones. We have 2 ones. If we looked at our fractions, we have 3/8 over here. And we're adding 5/8 on this side. If we were to show this addition problem on our number line, let's start at 2 3/8. And we're going to add 5/8. Oh, I spelled eighths wrong over here. I forgot an H. We're going to count over 5/8. Count up with me by counting up 5 jumps. 1, 2, 3, 4, 5. When we added 5/8 to 2 3/8, it brought us all the way over to 3. So the fractional units have a sum of 1. If we added 3/8 and 5/8, they would equal a total of 1 whole. We were already given 2 wholes to start off with, so we could have added that in to give us our final answer of 3. You guys are going to continue adding fractions and mixed numbers together. You'll use different models, either drawing or using a number line, to help explain. Remember to take your time when modeling your different methods of finding your answer. Good luck, mathematicians, and I'll talk to you guys soon.